All right, before we actually get into 4 dash, I do believe it's 4-3. So we're actually still in chapter 4. This is part B, and I'm going to be talking about 4-3, which is truth table. Before we actually get into that, I want to talk a little bit about Boolean algebra. Boolean algebra has rules to it as any, it's like mathematics. They have rules. Boolean algebra has rules. First of all, when we look at Boolean algebra, and I brought this website. This is from Electronic Tutorials. Which is great because this actually explains to you what some of the Boolean algebra is going on. So this is A, and they say A in parallel with the close. So basically, remember 1 is high, so it is closed. So if we look at a switch being open is being off, so it'd be 0, and if it's switch being closed, it'd be a 1. So if we look at this A in parallel with closed, so that means that switch is closed right up here. So this is saying that if you take A and you're going to OR with a high, anytime high, you're going to get a 1. In this case, if you're going to actually take A and OR it with a 0, you're going to get A. Well, this basically says what the OR gate does. This basically is the fundamentals behind what we've been talking about in the beginning of the OR gate. So basically, anytime you're going to have A could be anything. A could be 1. If it is 1, then we know it's going to be 1. If A is 0, then this is A is going to be 0. So this is called the identity property. So A in series with closed A, this is just A enclosed with A and 1. This is A and 1. So this is and. So this A and 1 is going to go to A. Well, it makes sense because A is 0. 0 and 1. Well, that's going to be 0. 1 and 1 is going to be a 1. So these are pretty much a good foundation behind you understanding some of the Boolean algebra. If we keep going on this, you'll see that this follows basically the idea behind what we were building on in the beginning of logic gates, is that anytime you're taking, for these guys right here, this one right here is the AND function. This is the AND. If you look at this is an AND function. Parallels is OR. So this is what we've been talking about for a long time. Hopefully this is going to give you an idea of a better understanding of the gates being visually through visualization here. So if we keep going down and we keep looking at this, we keep going down, some of the other properties that we need to look at are really important that I'm going to bring up because we're getting into that 4-2 here is right here. This is 4-2 is right here. This part of what we call the complement. So A OR with A naught is always going to be a 1. A OR with an A naught is equal to 1. That one you must know. This A and A naught is going to be always 0. This is going to be very important because we're going to be using both of these very shortly here. So remember, when you have an AND operation going on and you are inverting it, if you're inverting the A or the B or the C, whatever it is, so this is A and A naught is equal to a 0. If it was B and a B naught, it would be a 0. If it's C and C naught, it would be a 0. So these two have to be the same letter, but one has to be inverted. Likewise, this one's the same way. These two are the same letters, but one has to be inverted. And if they're inverted, then it's always going to be a 1. All right, so what we took a look at some Boolean equations there and some laws there, and what we're going to do now, apply them. We're just actually going to apply them to this. So basically, if I take this truth table I created, and this is from just out of the air. So basically what I have is my inputs here and my output here. And if I take A and B, these are both low, and I said low is inverted. That's been talking to you about that for a long time. So this, you can write it both ways. You could do it with a line across, or you could do it with a little, we call it apostrophe right there. And likewise, 1 is equal to high, and that is mean no inversion, meaning that it's just high. So what we're looking for in these truth tables, we're looking for the 1s. So in this case, we got 2 1s. How do we generate these 2 1s? Well, this is A naught and this is B naught, because these are low. And this one's A and B naught right here. So that's how I wrote these. So this is A naught and B naught, A naught and B naught, and this is going to be A and B naught. So now what we have to look at is, okay, I got these two Boolean equations. What can I do with them? Well, when we look at truth tables, when we're putting things together in these truth tables, anytime we have two expressions, we have to order them together. So this one or this one will give us some sort of output. So that's what I did here. A naught and B naught is right here, and A and B naught is right here. And then I took it and I put an order right here. So remember I told you in the Boolean laws and stuff, there are certain things we could do. There's certain things we can do. There's certain things we can do to simplify, to make these equations more simplified. And when we do this, there's going to be certain conditions that are going to happen throughout this, just like in mathematics, which we can apply, and then we can use those to simplify these equations. So, for example, we have here an A naught and a B naught, and I have an A and a B naught here. Well, you notice that the B naughts are both inverted, so I could bring that out. So that's what I did right here, is bring that out. Well, based on this is like doing mathematics, what's left is I have an A naught ordered with an A. So that's what I did over here. An A naught is ordered with an A. So remember in the equation that we just did, and if I look at it, A or A naught is equal to a 1. Well, that's what this guy is right here. This is going to be a 1 right here. So if we look at this, this is going to be a 1 right there. So if that's a 1, that just leaves me with, that's going to leave me with just B naught right there. So Y is equal to B naught. This is the simplified version of this truth table right here. Let's do one more. Let's do one more, and I'm going to go and try to bring up another lecture video on Boolean algebra so this gets a little more clear. But if you had to create these things right now before we actually get deep into Boolean algebra, I would accept this as a correct answer for now, and then eventually what you'll be learning is how to actually simplify these down. And there's ways to do it, and I'm not expecting you to be engineers. But I just want you to have the foundations of understanding how this all works out. So that's what this course is about, is understanding digital electronics. So, and I really wanted to get into the understanding of it, but not into the full theory behind it, because that's engineering, so the full theory. Just to give you a basic idea what's going on. So let's do this. Let's say we have A, B, C, and a Y. Let's say I do my truth table 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Let's say on my output I got some sort of digital logic going on here. And let's say that this is 0, and let's say that's 0, and let's say that's a 1, that's a 1. That's going to be a 0, that's going to be a 0, that's going to be, let's do this. Let's do 3 of them, 1, and let's do a 0. So we got 3 of them. We have 3 1s right here. We have identified 3 1s right here. So it's right here. Bring this down a little bit. Okay, so we have 3 1s. There's my first one. Here's my second one. And here's my third one. So let's look at this. Well, let's write this out. Let's write them right next to each other. So we're going to have A naught, because that's 0. So it's going to be A naught. B is going to stay the same. It's not going to be inverted. And C naught, because it's inverted to 0. Likewise, the second one is A naught again. And then we're going to have B and then C, but they're not inverted. And the third one. So we're going to have third one down here. Let's see. We have A, B, and then C naught. So let's see if we can put this together. First of all, let's just put this into a Boolean expression. So I'm going to write that up here. So I'm going to start with this one: A naught, B, C naught, or with, I'm going to put these in parentheses so we can do this just the right way here. A naught, B, C, A and B and C. And then we have ordered it with A, B, C naught. And that's equal to Y. All right. So technically we can start pulling things out. We can pull things out of here, and and make it simplified here. But if you gave me that, that would be the correct answer. But let's simplify.